All right, welcome back to JP Smart Solutions Limited. Today is our second day in the series 14 days masterclass on power system design, analysis, and protection. My name is Ekwe Jesse, and these are our contact info. You can call us using this number, or alternatively, you can send us a WhatsApp message on this number. Now, sequel to our training yesterday, we were able to cover a wide range of functionalities. We've been able to cover Module 1, which is an introduction to power system design, analysis, and protection. We talked about the concept of power systems, the concept of power system design, the concept of power system protection, the concept of ETAP software, as well as its applications in power system design, analysis, and protection. So we moved further into module 2, which is the modeling of electrical power systems. So we talked about concept of power system modeling, an introduction to single line diagrams, and basically we said it is also known as a one line diagram, which is a single line and standard electrical symbols to represent all three phases in a power system network. So just a recap of the summary of single line diagrams. We said a single line diagram is actually a part of the initial stage in electrical design. A single line diagram is used for basic reference by management and engineers for planning and costing phase of any project. A single line diagram also provides a basic roadmap to the interconnections of the electrical system and serves as a building block on which all types of system analysis are based, be it your power flow analysis, your short circuit analysis, your transient stability, or motor starting analysis. All this require your single line diagram. And lastly, we said it is mainly used for working out panel schedules, load schedules, fault analysis, protection system design, and the likes. So, from our session yesterday, we were able to look at the basics of ETAP software. That is a general overview of ETAP software. And we used ETAP version 24. Now, in today's session, we are actually going to be focused on this hands-on exercise, which is modeling of a primary distribution network using ETAP software. So at this point, I am going to switch over to ETAP version 24. Yes. All right. So this is actually the file which we created during our session yesterday. And as we explained, we have this section. This section is the mode toolbar, while this is for our equipment. Now, we said modeling a single line diagram. And we are going to be carrying out the modeling of a primary distribution network. But first, before we move directly into the power system, this is the network which we are going to replicate. Over here. So this is the example. We are going to be modeling this system. But before we do that, let's learn a bit of the basics on ETAP, on how to model, because we can see these are our equipments which we are going to use to model, but then how then do we actually use it in the modeling? Now, first things first, as I mentioned in the previous session, if we are unaware of the equipment, maybe we are not familiar with the standard symbols, ETAP actually gives us an approach to mitigate that. Once we take our cursor over to the equipment, it gives us the name of the equipment. So let's assume I don't know and I'm looking for a transmission line. All I have to do is keep hovering around each equipment until I get it, and I can see transmission line. So now that we have done this, we can easily identify equipment. How do we use these equipment to model? Now, we have two approaches of modeling single line diagram on ETAP software. I call it the manual mode and the automatic mode. Now, when I say the manual mode, you are actually doing the work by yourself. And I'm going to be giving an illustration. Let's assume we want to model a simple system for this illustration. Maybe we need a power grid, a source of power, so we can have our power grid. To get this equipment from this section into our workspace here, all we need to do is click on the equipment and drag. You can see it's following us. It's following us anywhere we want. And then we drop. You can see our power grid is here. That's all we need to do. Next, assuming we want to connect this, assuming we want to connect it to a bus bar. Now we need to find the bus bar first. You can see our bus. We have the bus bar and we have the node bus. So let's use the regular bus bar. I click on it and it follows me. So let's keep it over here. Now let's ignore ratings of the grid, ratings of the bus bar, such as voltage ratings. ETAP will automatically assign ratings since we are ignoring it. But then, to connect this power grid to this bus bar, it is actually very simple. All we need to do is take our cursor to the power grid and hover around it until we see there's a pink dot there. Once we see this pink dot, that is our connection pin. That is the point of connection. So we click on this, and as you can see, now it's giving me a connection line. We can drag anywhere we want. But we said we want to connect this power grid to the bus bar. So to get that done, we take this connection point to the bus bar. Now, at this point, it's looking like the arrow is on the bus bar, but it is not yet on the bus bar. For us to know that it is able to connect once we remove the arrow, the bus bar must also turn pink. So, for example, I take it down more, you can see the bus bar is changing color, black, pink, black, pink. So, once it is pink and I click on it, we now have a connection. We've successfully connected the power grid to the bus bar. Let's say we need a transformer. We go through the same process. We click on it and this comes up. We drop the transformer here. We can see the connection pin is already showing. You can see this is for the primary side of the transformer. This is for the secondary side of the transformer. So to connect this transformer to the bus bar, all we need to do is get the connection pin. We click on it and we have our connection. Take it to the bus bar. The bus bar turns pink. We click on this and we've successfully connected the primary of the transformer. Assuming we want to connect the secondary of the transformer to a bus bar, we bring out another bus bar and we drop. Then we go to the connection pin, click and drag. And finally, let's assume, okay, probably a cable, or okay, let's have a load. Or should we? Okay, let's use a cable. Let's say at this point of the system, we need a cable or probably a transmission line or whatever. Let's just take a transmission line or a cable rather. We click and we drop. We have our connection pins for the top and bottom part of the cable. We click, the bus bar turns pink, we connect. Now, the question is this: what if on this bus bar now we wish to connect another cable? We get the cable, maybe we wish to connect extra two cables, one on the left and one on the right. So we drop the cable on the left, and then we get another one, we drop the cable on the right. Now, how do we connect all three of them to the same bus bar? Considering the fact that this bus bar space is actually very small, can we connect? Yes, we can. We take this over here and we can see ETAP automatically gives it a path. We take this over here and we can see, but it's looking a bit congested, right? So to mitigate this, we can actually delete our connection points. Just click on the connection line and tap delete on your keyboard. So it actually goes off. Click on the connection line, tap delete, and that goes out. That's one. Now, to make it look a bit more presentable, we come to this bus bar and we click on it. The bus bar turns red, which means we have selected it. Now, what we need to do is extend the length of this bus bar. In order to do that, we simply come over here. Once you take your cursor to the edge of the arrow, the edge of the bus bar, you see it changes from a cursor to a two-edged arrow. Once you have this two-edged arrow, you click and you can expand to however long you want. You can see our bus bar has been extended. So we can do the same thing over on the second side. Click and we have our two-edged arrow. We click and we extend. We have an extended bus bar. So we can just easily connect this and connect this. And we've connected. Okay, so let's say we want to connect individual bus bars to these cables. We can, now we need three bus bars. Let's assume that. Let me move this. And we said, okay, each of these cables are feeding their own independent system. So we need three bus bars. This is another easy trick. Now, instead of coming over here, we click, we take one bus bar, we drop here, we come over here, we click, we take another bus bar, we drop, we come over here, we click to take the final bus bar drop. We can simply come here, and instead of clicking once, we click twice. That is, you double click. So double clicking on this bus bar, I take it over here, and I drop the first bus bar. You can see my cursor still has the symbol of a bus. I drop the second bus bar, it still has the symbol of a bus. I drop the third, and I can drop as many as I want. Okay, now that I have gotten three bus bars, I required three bus bars. What do I do with the remaining bus bars? All I need to do is take it back to where I collected it from. And then I click on this arrow, selection pointer. Once I click on that, we have our arrow back. So we can connect the cables to the bus bars. Connect the cables to each bus. Then let's say, okay, we need a lump load on each one. We can just, this is lump load, this is a symbol for lump load. So we double click and we put 3 lump loads. Okay, so we take it back to the pointer and we are good to go. We connect. Now, this is the manual approach of modeling your single line diagram. Remember I said we have the manual and we have the automatic. Now, let's go into the automatic. When I say automatic, I don't mean you just maybe, okay, I want this system, type in some magic code and it just pops up. No, that's not what I mean. I mean we have an easier approach, a much more faster and efficient approach. Now let me move this one we've modeled over to the left. So let's try our faster approach. We are still going to remodel this system now. We are going to make it using the second approach. This second approach is known as the one-line auto build. The auto build. Now, let's get our power grid. This is our power grid. And we jump here. Now, we need a bus bar to be connected to this power grid. All we need to do is enable this one-line auto build. Where is this one-line auto build feature? This is it. Auto build. So once I enable this, I come over here. I want something connected to the power grid. So I click on the power grid. Did you observe? Take a look at this part. They are grayed out. If I don't click on the power grid, we have them. But once I click on the power grid, they are grayed out. The reason they are grayed out, remember I said this method is also much more efficient. They are grayed out because you cannot connect this equipment directly to the power grid. So ETAP has this feature to show you equipments that are compatible directly or equipments that require something to link them. So this one-line auto build gives us that feature. So we can see equipments that are easily compatible and equipments that require a third party to link them together. So now we said we need a bus bar. We can see, okay, bus bar is compatible. Now, do we click and drag? No, we just click. So if I click here, we can see the bus bar has already been drawn. And it gave it an automatic voltage magnitude, which is 330 kV. Now, if you want to change this voltage magnitude, we'll do that when we are modeling the actual system. But at the initial point, if you want to give it a specific voltage magnitude before modeling it, we come over here, kV to apply to selected bus. This is it. So once we enter the voltage magnitude here and we select it, that is the voltage magnitude the bus bar will assume. So moving on, we said we need a transformer, a two-winding transformer. So we click on this bus bar to continue, and we just go over here, we click on our two-winding transformer, and we've gotten it. And we are supposed to continue to bus 2. We need another bus bar. We click on the bus bar. So at this point now, the problem is that we need to extend the bus bar. Now the auto build feature cannot extend the bus bar for you. You have to manually do that. You have to manually extend it. So now we need cables connected to it. If we select this bus bar and we select the first cable, we need another cable, but we want the cable to be connected to the bus bar, right? But at this point, it is the cable that is selected. So if we click on another cable, we are connecting a cable to a cable. So we come back and we click on the bus bar and we click on cable. We have another cable. We come to the bus bar and we click, then cable. We have another cable. So we can now move this cable over here. We click on it and drag down to this point. Or we can extend it a bit. Okay. Then we have individual buses, right? So we click bus, we come over here, we click bus, we come over here, we click bus, And we have the 3 buses, then we have a lump load on each. So we get our lump load and we click 1, 2, and 3. So we have the same system, this and this. Now, one more trick. There are actually multiple tricks in this modeling of single line diagram. We can model complex networks, very large networks, and we can just put them into a very small network. But then this is of importance as it will save time. So we have this. Let's assume I want to create a replica of this system. There is a feature known as templates. There's a feature known as templates. So let's say I select this system and you come over here. I can see add to OLV template. OLV means one line view. And I click OK. Let's add it to the template. It comes up instantly. So let's call it template number 5 and I save. Following one line view template file was generated successfully. I click OK. Now, remember I said I want to duplicate this section. We want to duplicate this. I come over here and I choose get templates. It gives us a list of available templates and I click template number 5. It gives us a preview of the template. I click OK and we have the exact system replicated here. So I move it to this point. I can take our power grid bus bar over here. I can connect this to the bus bar and we can just have the power grid over here. You can see we are gradually building a system. So that's for the templates feature. An easy way to identify that it was done using templates is this. Observe this one, the name is bus 7. This one is bus 7-1. This is cable 5, this is cable 5-1. That is an easy way to identify from the cable ID, from the equipment ID. Now all these can actually be changed, it can be modified to your preference. So that's that for modeling using the manual and the automatic mode. So I'm going to check for a few questions, then we proceed into the actual modeling. Is there any question? You can drop your questions using the chat. Any question? Okay. Okay. So far so good. I don't think there's any question. So we can proceed. All right. So from this is the system that we are actually going to be working on. So we are modeling this. So I can go ahead and clear my workspace. Let's just select all this and delete. Now remember I told you something in the section yesterday. I said when you delete equipment, it doesn't go. It actually moves to the system dumpster. So if I open the system dumpster, I'm seeing what I just deleted. So once I'm seeing that, I need to delete it again. And now I've deleted both from the system dumpster. I can return to our one line view and I have my workspace. So now we are modeling this system. We need over here, we have a power grid. Let me zoom in. Yeah. Okay. So over here we have a power grid, and this is a perfect example because You know the one we modeled before using the manual automatic mode, it came from top to bottom. Now this system is coming from left to right, moving in this direction. So it's usually an issue for some persons. Now, the first thing we need to do is get this power grid. So we come over to ETAP and we locate where is the power grid, where is the power grid. Then we come over here, okay, we've gotten the power grid. We click on it and we come here. We drop. Now remember, it's supposed to be at this point, but we are having our connection pin at this point. So we need to rotate the equipment. This is our connection pin. We click on the equipment and press letter arrow. You can see it's rotated, arrow again, it's rotated, and the final arrow. So we have the connection pin on this side. Well, now we have ratings of this power grid. Power grid is rated 100 MVA short circuit. That's 100 short circuit MVA. And it is feeding a 33 kV bus bar. So the power grid is rated 33 kV. So we come to ETAP software and we click on, we double click on the power grid. This dialog box comes up. This gives us the ability to enter ratings of this power grid. So we come to the rating page. We say the voltage is 33 kV. We enter it. And the short circuit MVA is 100. So we just come over here and enter 100. We click OK. Now remember, we need to connect this power grid to a bus bar, and we still have our auto build feature on. So we click bus and it is already connected. Now this is one of the disadvantages of the auto build feature for such a modeling. If you observe the ratings of the bus bar, this is it. It's conflicting with the ratings of the power grid. So we are going to have to manually move the ratings around. You can see. Then we return the rating of the power grid. Okay. So we have the power grid to bus bar. We proceed. We need a transmission line connecting bus 1 to bus 2. Connecting bus 1 to bus 2. So we click on bus 1, then transmission line, then bus bar. Now we can see we are having the same issue, so we still just move it. And now we have some transmission line parameters over here. We said, okay, the length of the line is 7.5 kilometers. It is aluminum. The type is Cricket 1120. So we come over to ETAP software and we open the line. By double clicking on it, this dialog box comes up. And over here we can see the length. So we said 7.5 kilometers. So 7.5. And over here we have the unit kilometers. So we can choose between feet, mile, meters, or kilometers, depending on your preference. Then that's not all. We come over to the parameter page. Now, on this parameter page, the type of conductor was specified that it is aluminum. Then now we need to go into the conductor library of aluminum and pick. It said Cricket 1120. So I use the software so I can easily know that Cricket 1120 is under this Pirelli here. So we can see this Cricket 1120. So we select this and click OK. Now you can see these values have been updated. For us to carry out a load flow analysis, we are going to be needing this value, but for the purpose of modeling this single line diagram, that value was not given. So we'll stick with that. We click OK. Following our single line diagram, we have a 15 MVA transformer next. A 15 MVA transformer to a bus bar, bus 3. So we come over to our software and repeat. Click on the bus, a 2-winding transformer, and we can move the ratings. over here. Then we open the transformer by double clicking on it, go to the rating page. Now this transformer that we see is 15 MVA is converting 33 kV to 11 kV. So it is a step down transformer. Stepping down 33 kV to 11 kV. So we come over here. The primary voltage is 33 kV. The secondary voltage is 11 kV. So we enter 11 and we say the power rating is 15 MVA. Now once we put in the power rating and click anywhere on the screen, ETAP automatically calculates the full load current in amperes in both the secondary and the primary windings of the transformer. We can see for 33 kV we have 262.4 amps, for 11 kV we have 787.3 amps. Now ETAP doesn't stop there. If we come over to the impedance page, for example, the ETAP single line diagram we have did not actually specify the impedance of the transformer. So let's assume we don't know the impedance and we don't know the XR ratio of the transformer. We come over to this page, we have typical Z and XR or typical XR. So ETAP has a vast library of transformers. That's a vast library of cables. That's a vast library of transmission lines. Vast library of induction synchronous motors. So we have manufacturer's data embedded in this library. So ETAP considers the rating of this transformer you have put and calculates the impedance and XR ratio of this transformer. So it has automatically given us the impedance and XR ratio. Now, we click OK and we connect this transformer to the low voltage bus bar, which is 11 kV. The voltage magnitude is automatically set since we are using auto build. So we can just arrange the ratings. So next, if we check this, we can see, okay, we have another transmission line to a bus bar, then a transmission line. So we have extra two lines. So coming in, we click on this, and we have a transmission line to a bus bar, another transmission line. All right, and we can do this. Now let's verify. This transmission line length is actually 7.5 kilometers, still the same parameters, aluminium cricket 1120. Now this is 8 kilometers, still the same parameters, aluminium cricket 1120. So we come over here, 7.5 kilometers. We come to the parameter page and we select conductor type to be aluminium, then conductor library, cricket 1120. Okay. I click OK. Now this is 8 kilometers. This is 8 kilometers. And then parameter page, aluminium, conductor library, cricket 1120. Okay. So now if we check, we can see that, okay, from this, we have this long bus bar over here. So we have this bus bar in which all these distribution transformers are connected. We have 1, 2, 3, 4, 5, 6, 7. We have 7 transformers connected to the bus bar. So we connect to the bus and extend the length of the bus bar. Now, note that distances between each equipment can be extended. For example, if I want this bus bar to move further, I can actually click on it and drag it, depending on where I want it to go. Also, similar to the transmission lines, we can actually move them as much as we want. So it doesn't have a fixed point. So Now we said we have about 7 transformers on the bus. So let's take this. Now at this point, I would recommend you go manual or you continue with your automatic. Now I'll continue with automatic to show you why I recommend we use manual mode. Now we said we have 7 over here, 7 transformers. Let's impute the 7 transformers. If I click on the first transformer, this is where it starts from. I come back to our bus bar and I'll click again. Another transformer. It comes over here. Remember, we want the transformers over here. But if we are on manual, we turn off I just turned off the auto build now. And then I come over to transformer and I click it twice. We have 2 transformers already. So we need okay, before I do that, let me take this transformer 2 and 3 up so we can have more space. Transformer 2, transformer 3. So we need transformer 4. So we have 1, 2, 3, 4, 5. We already have the 5 transformers. Now, remember, we need to rotate the transformers. So we rotate it. Take note of this while rotating the transformer. At this point, this is the primary of the transformer and this is the secondary of the transformer. Take note of that. So if we rotate once, yes, it is looking like it is in the direction we want. However, this is the secondary of the transformer. So we don't want the secondary of the transformer here, we need the primary. So we rotate again until we get it. And we move this over here and we connect. We do the same thing over here. Do the same thing over here. Do the same thing over here. And lastly, the same thing over here. Okay. So we can actually move the ratings of the transformer to the top of the transformer. Alright, so let's check what are the ratings of the transformer. This first transformer is rated 0.75 MVA and it is stepping down 11 kV to 0.415 kV. Then the remaining transformers are 0.5 MVA, stepping down the same 11 kV to 0.415 kV. So 0.75 MVA, we come back. This transformer is actually 0.75 MVA. We come to the rating page, similar to the first transformer we put. Stepping down 11 kV to 0.415, power rating 0.75 MVA. Automatically calculated the full load current and amps. We don't know the impedance, so we just click. Alright, so at this point we are actually done modeling the transformers at this point. So from our single line diagram here, we can see that each transformer is connected to a bus bar and to a lump load, bus bar and a lump load, bus bar, lump load. So we just need to replicate the same thing on ETAP software over here. So we turn on the auto build feature and we just connect the bus. Then we connect the lump load over here. We come over to this section and we do the same thing. We connect the bus and the lump load. Here we can see the ratings are clustering, so we can easily just move this and rearrange. Okay, so we've gotten the rating. So we can do that across all transformers and buses. So let's just run this through a bus bar and a lump load, a bus bar, and a lump load. Over here, a bus bar and a lump load. Here, a bus bar and a lump load. And finally, a bus bar and a lump load. So we've been able to get this. The last part of this is entering the data for the lump load, and we can see each of them is 0.338 MVA. So we double click on the lump load, which opens it up, and then we come to the nameplate. On the nameplate page we can see this, so we just put 0.338 over here, 0.338. Now we know that each of the other lump loads are rated 0.338, so all we need to do is click over here to move to the next lump load, or we can use this drop down list to easily identify anyone. So if we click over here, we just need to enter the value 0.338, 0.338, sorry, 0.338, yes, and we do the same thing for every other one. 0.338, 0.338, for 0.338, 0.338, and finally lump 7, 0.338. So if we move again, we are saying we're back to lump 1, so we can just click OK, and we are done with the modeling. Now, making this look like this, it's simply based on your arrangement, so we can actually just extend this and extend this, extending each of them. So basically that's how we get our single line diagram model. Now, as I said, we are actually going to be continuing this course on other modes. For example, this is our training syllabus which we are using. So far we've been able to cover for modules 1 and 2. We're able to cover this and we're able to cover this. We just finished a hands-on exercise on modeling of a primary distribution network using ETAP software. So in tomorrow's session, we are going to be focusing on module 3, which we have power or load flow analysis. So work on this tomorrow and subsequent days until the training is over, which is scheduled to hold for the next 12 days. We'll be finishing power flow analysis, voltage regulation, power loss minimization, which is module 4. Module 5, short circuit analysis. Module 6, we actually move into power system protection. And we are going to be considering 3 protection schemes as we earlier stated. The overcurrent protection scheme, in which we are going to use a circuit breaker for short circuit protection, and then we are going to use overcurrent relays for protection of motors, cables, and transformers. So we are going to be talking about the instantaneous protection and the time overcurrent protection. Now we also have hands-on exercise which would include relay settings calculation and relay coordination. We are also going to design an overcurrent protection scheme as earlier stated for motors, cables, and transformers. Then we move over to the second part, which is differential protection scheme. Then we move to the final part, which is distance protection scheme. So we are going to be carrying out all these hands-on exercises in the course of this training. Now, to continue being part of the training, all you need to do is send us a message via WhatsApp using this number, or you call us using this number and we'll respond to you as soon as possible. Once again, thank you all so much for being part of this training. Kindly reach out to us for your certificates and it will be sent to you. Just send us your full name and your email address. Thank you so much and do enjoy the rest of your day.